Hello everyone. Today I'm going to talk about Google Map system design, and I'll try to make this course a micro-learning content so this can be easily digestible just before your interviews. So let's talk about functional requirement first. First service we want to develop is identify location. This service basically captures the user's latitude and longitude from their mobile devices. As we know, mobile device can precisely detect your location on the world map using GPS. So we're gonna send these two details to the server, identify location service, and the next service we want to develop is to recommend route. So this service is going to take the source and destination from the user in input field, and then this service responsible for returning the couple of routes, optimal route to the user. Next service we want to discuss is the give direction service. This service is kind of a navigator going to take the user's live location, lat and long, and it is going to also talk with the area search service, which we're going to talk in the next part of this video. So this service is going to collect the lat and long, and it's going to return the, like, let's say if the user get deviate from their path, so this service is responsible for sending them the right suggested path. Let's move on to the non-functional requirement. So first thing we want to discuss is availability. So as you know, like, the service is going to be used by million of users, and we want this service to be available all the time. Next is scalability. So in the beginning, the user base is going to be less, but as the user base grows from million to billion users, we also want to make sure that the system is less response time. So once a user enter the source and destination in order to get the route, we also want to make sure that they get the route as soon as possible. We don't want user to wait more than 2 to 3 seconds. So let's talk about the high level design. So let's assume there's a user who is using Google Map through their mobile device, and they make a request. So this request is going to intercepted by the load balancer, and the responsibility for load balancer is to divide the request or to send those requests to their specified servers. So we have three services we already discussed in our requirement section: location finder, a route finder, navigator. So once we get the lat and long of the user, we're gonna send that to the route finder service, and the route finder service is going to forward those lat and long to area search service. The responsibility for area search service is to collect the correct, you can say, the it can return the multiple route to the user from source to destination, and this is going to search first. This is going to search the system, and distributed search system is basically gonna have a mapping of lat long place name, and this area search service is going to also collect those lat long mapping and pass it to the graph processing service. So the responsibility for graph processing service is to find the shortest path between two source and destination, and this is going to save all the process into the DB graph DB. We are data graph data, and once we get the shortest path, we're going to return it to the user, to the route finder and path. Now let's discuss one scenario when, let's say, user get deviate from their path. What happens then? So in that case, this is going to save the user. So the work for this navigator service is to collect the data, to collect the lat long at a specified time. So you can say the user is going to hit this navigator service every uh, and it will be sending their lat long. And this navigator service is also going to collect the user's data from that area. As is going to be in as the data is going to be very huge, so we want to introduce Kafka here. So all the events going to get passed through this Kafka system, and then this data will be, if the user get deviated, this data will be passed to service, will again gonna suggest the user the correct path with the help of graph processing service. When the data live data get passed here, this data will be sent to the graph building service. So this service will be responsible to building the graph based on the new lat long the user has just be saved into the database, and area search service going to database, and it's gonna pick the data basically build the or suggest the route between two paths, or you can say the shortest path between two distances, source and destination. So let's assume this is our Earth, and in a very small segment we gonna have the source and destination. Like let's say if the user has to go from this lat long to this position, so how we gonna suggest that path? So let's move on to. So let me move this little bit here. Let's assume that these squares are miles 5 cross 5. So for this case, we are taking it as a square. It has to go from shine Harding formula to calculate the aerial distance. And so let's say a user has to go from A to V to use the shortest path. You can even use Dijkstra algorithm. So here we're going to use the shortest path algorithm, and we're going to assign the weight to all these edges. And let's say user has to go from A to F. So our algorithm is going to assign all the weight, and then it's going distance based on the weight. And as you know that we are also collecting from the area, so this service will also so we can also predict the ETA based on any blocker on the road, because all the local devices will be sending their GPS data, and then Google will be getting those data, and based on the algorithm it's going to assign some weight to those edges, and then it's going to calculate all the edge weight, and it's going to find the optimal. As we can face is scalability. So one of the challenges is scalability. So as you know, so as we know, there are millions and billions of nodes and edges, and computation calculation. So we have to calculate the ETA by considering distance, traffic. Yeah, so the course ends here, and topic, and I've not gone through in depth. So stay tuned, and there I'm gonna talk about these topics in more depth.